And hello, welcome friends. Welcome back to this video. I'm going to continue on the MATLAB series where I try to turn all of this frequency response data into a transfer function. Okay, and yeah, let's explore some scripts and maybe modify existing scripts so that we can extract a transfer function from this. Yeah, and that's the objective of this video. So last video we have already gotten our potential data that we need for a CSV file so that we can have a good complex gain and whatnot, complex gain and the relevant frequencies. You can get that CSV file. Okay, so let's look for Excel or LibreOffice calculator. So I'm going to copy all of this on the MATLAB window and I'm going to paste it here. That's the complex frequencies, Control W to close, and the complex gain is over here. Okay, and what I want to do is to go to CSV to transfer function, and let's use a different set of test data. Okay, I'm going to save this over. I'm going to save it as a CSV. I want to save it. Yeah, I want to save it into my MATLAB part, CSV to transfer function. I'll just put it here maybe. I'll save it as my test data because this is much nicer. There's a lot of beefy data over here. Okay. So this is the test data CSV, and as said before, we should be able to use this transfer function. Okay, so let me load this test data into this frequency transfer function MATLAB script. Now first, like I said before, we need to load it into a IDFRD file, and the function is over here. I did say how it's being done before, or at least the basic idea. So I load this CSV file into an array, into a body array. Okay, body array equals to CSV to array CSV file. What CSV to array does is just to take the table data and put it into an array where the first column is frequency and the second column is the response, or the complex gain, as I like to call it. I think the more proper name is called response, but you know, yeah. So well, we have also to get our Nyquist frequency. Okay, Nyquist frequency. But technically, how do we get our Nyquist frequency? It's a little bit hard over here. Okay, it's hard to see from at least this part. Where is our Nyquist frequency? Okay, let's change folder. Yeah, Nyquist frequency, well, there's a few things you need to do. Now you can see that over here the thing isn't quite symmetrical. I think there are a few pieces of data missing for some reason. I have no idea. Okay, yeah, so this one is kind of an assumption you have to make. Okay, yeah, this part is kind of a bit iffy because I don't quite have data for this part. Okay, close this. I don't quite have a good mirror image right here. I don't quite have a good mirror image right here. See, here my mirror image is not so good, and a few pieces of that data is kind of missing. But at least from this graph, you can see the Nyquist frequency is around 10 Hertz. Okay, 10 Hertz here. Now, how do we use this graph? I mean, we use this existing data as it is. It's not perfect, but how do we then use this existing data, okay, to determine the Nyquist frequency? Okay, yeah, how do we do it? Okay, so if we take a look to the right hand side here, where there is like, you know, no data over here. I mean, there is data, and in fact there are a lot of peaks over here as well, given by the output, right? So yeah, the approximate way we can sort of determine this Nyquist frequency is to take wherever the maximum output peak is here, you divide it by 2. Okay, so where's this? If you take any one of these output peaks, alright, take any one of these output peaks here. Let's say here is like 19.89, for example. Okay, this output peak here has a frequency of 19.89, and you kind of just chop it in half. You divide it by 2. Now, if you divide it by 2, you'll get somewhere around 9 or 10 hertz, which is approximately the Nyquist frequency. Yeah, and that's how I think maybe it's a good idea to find the Nyquist frequency. All right, so so let's try looking at the Nyquist frequency here. Okay, sampling frequency is 2 hertz. Okay. Yeah, so if your sampling frequency is 2 hertz, sampling frequency is just whatever the maximum frequency is on your Fourier transform graph. Okay, and since you kind of load in your CSV file already, that's what you have here. Okay. Ay. Okay, this is messy. Okay. So basically here I don't have any data that can say, you know, which is the Nyquist frequency. Okay, which is the Nyquist frequency. Let me think. Okay, so anyway, yeah, the only reason why, okay, let me start from the beginning. So we have a CSV file. We want to convert this into a Bode array, and then we also need to load the Nyquist frequency or the sampling frequency into the we need to load the sampling frequency into the data plot. Okay, we need to load the sampling data frequency into the data plot. Why? It is from this sampling frequency that when you do a Bode plot later, they'll take this sampling frequency, divide by 2 to give you the Nyquist frequency. And the only way to get the sampling frequency, okay, the sampling frequency is to, the only way to get the sampling frequency is that you kind of have to supply it yourself. Okay, so right now I just manually gave it as having a sampling frequency of 2. Now, it might not always be the case that the sampling frequency is 2 hertz. In this case, it may look more like 20 hertz. So how do I know? It's around 20 hertz. Now, if I look at my output peak frequencies, I notice that the maximum the maximum data in this output peak frequencies is around 20 hertz. Okay, 19.88. Okay, close enough to 20. It's not exactly 20, but it's close enough. So this is something I probably want to take it. I want to take this data and I want to save it. Okay. Now I want to load that into my cases, into my how do you say? Yeah, I want to load that into my transfer function MATLAB script. Okay, so let me save all of this first. Okay, I will call this my frequency list. Okay, I will take LibreOffice. I'll save this as a CSV file. I'll quick. All right, I'll save it here. I will put this. I'll call this my list of frequencies. And I'll use CSV format, comma delimiter. Okay, I'll close this. I'll close this, and let's go to transfer function. Okay, here CSV ID to FRD test data.csv. Okay, so that's the first one. Okay, this is the first one. And now yeah, let's put the second one to be a CSV file. Instead of calling this CSV file, I will call this frequency response data. Second one is just frequency array CSV. So this one is a frequency response data CSV. The other one's a frequency array CSV. So yeah, let me find everywhere we have this CSV file, and I'll just put frequency response data CSV. Okay, so here, okay, so frequency array CSV, what's the use of this? Basically, I want to use this to help to determine my sampling frequency. Okay, let me do. Now I load in my sampling frequency. Maybe an estimate of it. Okay. Of course, the best way is to actually ensure that I have a perfect mirror of the left and right side in my body plot, or rather my Fourier transform plot. Me being lazy, I don't want to edit the code anymore. So I choose a little bit of a lazier way. Okay, I choose a little bit of a lazier way. Of course, that means that you have to check at every step whether things actually make sense. Okay, and the whole idea is that you only need the left side of the Fourier transform. Left side of the Fourier transform in order to have enough data for your body plot. Okay, I assume you know this already, so I will not go too much into detail. Okay, so let's have a CSV to array again. All right. Let's see. Okay, it looks like this CSV to array, it has to take two it has to take arrays with two rows, or two columns rather. So this list of frequencies is something I need to have two columns in order to like use it properly. This is a really crummy workaround, or maybe I'll just code a new batch to read a new code to read it. So this one is CSV to array. I'll call this two column. I'll shift enter this, and let's make a new function. Array equals CSV to array one column. Okay, now and put this CSV file in here, and I'll put n. So I'm just going to copy and paste all of this. Okay, table data equals to blah blah blah. CSV with the delimiter comma. Okay, response equals to table to array of this response. Okay, so what is this? These three lines actually deal with the frequency response part, which I don't really want anything to do with. I am not going to do response. I'm only going to use the first one, the first row. Okay, and in fact I'm just going to put array equals to table data the first one. Yeah. So this is all I need. Hopefully, okay. What am I doing in this code? Is a CSV to array with where the array is only one column. It will take in the table data, and I'll define it as reading. You have to read the table of this CSV file with the delimiter of a comma, because it's comma separated values. Once you have this table data, I can take out a frequency, the frequency array or whatever, and that will be in a table format, and I'll need to convert that into an array using table to array, and that array will be returned. Okay, so let's do that. Okay, so first I have to load my sampling frequency. So okay, max, I'll call it max frequency array equals to CSV to array one column. Which one is it? I need my list of frequencies.csv. Or rather frequency array CSV, and this is the one. Okay, fs equals to maximum of this max frequency array, ts equals to 1 divided by fs. Okay, so that's the sampling time. So this loads in the sampling time, by which that is going to load my Nyquist frequency. Okay, so once the Nyquist frequency is loaded, once the Nyquist frequency is loaded, it will be able to load it in here. So I'll need two inputs now. Okay, the frequency response data equals CSV to IDFRD. It will need two inputs. One is the frequency response data CSV, the other is the frequency array CSV. So the frequency array CSV will be called list of frequencies.csv. Okay. Okay. So that will give you the frequency response data. Now, remember in transfer function estimation, you can actually decide a delay time, how many poles you want, how many zeros you want. So what I do here is to define the delay time, which basically is 0. Okay. So delay time is usually the residence time, but well, we can say delay time is sometimes the residence time, but here we don't really have any residence time of the reactor or whatever it is. Number of poles is equals to 2. Number of zeros equals number of poles minus 1. Okay, fair, because you want to have a proper so-called transfer function. And then I use the transfer function estimation data here. It uses frequency response data, number of poles, number of zeros, and delay time. These are your settings of the transfer function estimation. And then you load this into a transfer function system, and then you can actually plot it out over here. Now this part I can explain it later, but let's try running the script, see whether it works. Okay, and look at that, this is beautiful. Alright, so this is a Bode plot. Okay, a Bode plot, and you can see a lot of frequency response data, and the gain is slowly going down. Okay, let's see how much time I have. Oh, it's almost 20 minutes. Okay, hopefully that was explained all right, but yeah, you can see that this frequency response data is a nice downward sloping Bode plot, and there's a lot of data here. Okay, and you can see the poles and the zeros, and we see what's the matching correlation rate. Here's 90.77%, which is very nice. And let's take a look at the phase plots as well. Okay, the phase plots are a little bit harder to match. Maybe the units are kind of off. Okay, but anyway, at least the body magnitude plots kind of match. Okay, but still, yeah, I think my units are kind of off here. Maybe we'll deal with that in the next video. Okay, can deal with that in the next video. But yeah, I'll explain a little bit more what all of this is. But hope you can see with hope you can see, like, you know, it's easy to plot all this out. All right. I mean, I think there's probably a better way of plotting. I just haven't so-called done it yet. But yeah, I'll just explain more in the next video. Yeah, but in this video, we just did some debugging. We imported the data to CSV, and then we put it into this transfer function estimator script, which uses transfer function estimator, that function from MATLAB. So what I do is that I convert the CSV into a IDFRD. It's a frequency response data kind of a thing, and then I estimate a transfer function system from it. Okay, and then I will have some ways to plot the transfer function. Okay, using some of the old manual functions, but there are easier ways of doing it. So I don't always recommend doing it this way, but this is one of the ways. I use a manual function. Okay, anyway, so that's a summary of this video. I shall see you next time. Okay, bye bye.